All right, so 2.7 in your textbook, this one is entitled Solving Problems Involving More Than One Right Triangle. And we've been doing very simple questions up to this point. An example of one that you know how to do is, let's say, here's a river here, and we've got, point A, and we've got point B, and we know that this station right here, maybe this is a lookout station or something, and this lookout station, there's a fire over here at B and a fire over here at A, and you're given that this is 25 kilometers and this one is 7 kilometers, and you're wondering how far the two forest fires are, how far are the fires away from each other, right? So this is a simple kind of question with one right triangle. So what we're going to be moving to is questions that are a little bit more complicated in the sense that there's two right triangles that are usually involved. So for example, a really common example of this type of question is this right here. And I want you to draw two sort of buildings, okay? There's building one, and over here you're going to draw another building that's smaller. Okay? There we go. There's a little door there, there's a little door there. Okay? Two buildings. Now, if we take a look at this example, actually is in your textbook, page 115. But if we take a look at this, the question might say, from the top of a 20-meter building, and here's our 20-meter building, a surveyor, so that's the person that uses instruments to measure distances and lengths and draws survey plans that show you exact measurements and dimensions of a property or something. A surveyor measured the angle of elevation to the top of another building. Okay, so where's the angle of elevation here? Well, from the top of this one to the top of the other building, that's where he's looking, the surveyor, and he determined that the angle of elevation to be a certain value. And it says he determined the angle of elevation to be 30 degrees. So that means from the horizontal, he has to look up 30 degrees to see the very tip or the very edge of the top of the other building. So right now you can probably see a right triangle here, right? Look at this. These buildings are straight up and down. Horizontal is straight sideways, so we have a 90 degree here. And you see one triangle. That's great. But in a question like this, if we continue reading, it says he also measured the angle of depression, okay, to the base of that building. Now the angle of depression, do you remember we talked about this in class? The angle of inclination or the angle of elevation goes up, and depression goes down. If you're feeling really depressed, you're feeling really down, right? So that's pretty easy to remember. We have an angle of depression of 15 degrees. And remember, this is a right triangle here as well. So now we have two right triangles in our question. And the question, the example actually says, the surveyor sketched this plan, here it is, determine the height of the taller building. So given this information, and this information only, you are asked to determine the height of the taller building. Well, this height, you can see right now that this height right here, this is the height we're talking about, that's part of two different triangles, right? So you're going to have to put some pieces together. Do we know part of the height of this building already? We do. What is it? 20. Look at this smaller building, and this is a horizontal line, so guess what? I know that this is 20 from here to here. I know that already, so that's going to be very handy. I need to find this part, right? Okay. So you would look at this and you might say, oh, that's pretty easy, Mr. Maxwell. I know what to do. All I need to do is find the opposite side to 30. And that's true. But the problem is what? We are not given this side length right here, nor are you given this length right here. So we don't have enough information, right? And so what we need to do is we need to start, we can't find this directly. We have to find some other information first. So these questions involve a couple steps, and you might have to back up. And what I suggest is you figuring out what you need to find. Okay, I need to find this to complete the problem, but I can't find it right now. So what other dimensions can I find? And you take what you're given and find whatever you can. Now, if you notice, okay, couple things. This triangle, it would be nice to have this measurement right here, or this measurement. Like that is how far the buildings are to each other. That would be nice to have. And if you notice on this triangle too, right here, this triangle, and I'll just blow that up for you here. So it looks like this. 15 degrees. We know this is 20. So guess what? We could actually find this distance right here, right? This length right here. And that's probably what we should do, because that will give us a piece for the second triangle. So this is what you do. You just think through it, and you find out whatever you can, and it's multiple steps, okay? So, how could I find x here, given this triangle? How can I do that? What trig ratio could I use? And, just in case you're wondering, you should write this at the top of your paper. Really, you should be writing this everywhere you possibly can, so that you can quickly see. Now, 15, we have opposite, and I'm looking for, what side is this according to 15? Adjacent. So opposite and adjacent, guess what? I need to use the tangent ratio. So, tan of, what's the angle? 15 equals opposite, that's 20, divided by adjacent is x. So x equals 20 divided by tan 15 degrees. Your x equals, so your calculator tells you that it's 74.64. And what would that be? What units? Let's see. The question says this is a 20-meter high building, so this is going to be in meters. So does everyone see how we've got piece number 1 here? I actually know that this side length of this triangle right here that we've drawn is 74.64. So if you see that we have one more piece left to find, and I do have enough information now to find that. So if I just draw the second triangle for you, just going to blow that up a little bit. That's 30 degrees. I know now that this is 74.64. And now I can find out what this piece is. So what trig function would I use here? Opposite, adjacent. Tan of 30, does that look right? Yeah? Equals this unknown piece divided by 74.64. .09 meters, yes? Okay, so now we see that this right here, it's gone. Okay, that is solved for now. That's going to be 43.09 meters. And so on our original diagram, this is why it's a good idea to draw a diagram, and one that's big enough where you can put values on when you find them. And so here we have 43.09, and the height of the building now can be determined. It's 43.09 plus 20 is 63.09 meters. It's a word problem, so you would finish off with a word sentence. You'd finish with a word sentence saying the building is 63.1 meters high. The question asks to round it to the nearest of the tenth, so that's your answer right there. Okay? Now think about this question for a second. This is a very typical kind of question that you'll have to do. Yes, there is a significant amount of work that you have to show, and you guys are getting better at showing work. I can tell as I'm walking around. Some of you are still a little stubborn, still don't think you need to show the work, but please, please, please get this habit formed right now. Do a diagram, okay? Show all your work for each piece. Label your diagram as the pieces, are found. Show your work. Label the diagram. Show your work. Circle your answer. at the end. So put all those pieces together. Okay? Questions? Example 3 says this: from the top of a 90-foot observation tower, so we have this observation tower that's 90 feet, a fire ranger observes one fire due west, similar to the question that I started with, but this is a little bit more complicated, it's a bit three-dimensional here. Observes a fire due west of the tower at an angle of depression of 5 degrees. So let's say that the fire is over here. Okay, there's the fire. And he's up here observing, and he observes the fire at an angle of depression. Now remember, the angle of depression is always from the horizontal, so it's up here, 5 degrees. Okay? And I'm going to draw this three-dimensionally. So this is due west, it says. And another fire due south. Now the significance of these directions is that we have west and we have south, right? So north, east, south, west. So if he's looking west and then looking south, that's a 90-degree angle between there. So let's say that we have this is due south, and the diagram's in the textbook, right? So you can kind of study the diagram to see kind of how we're coming up with this. But we have an angle of depression here for this fire of 2 degrees. Just fix that. 5. Okay? Now, this is what you have to wrap your brain around. This is sort of kind of an attempt at a three-dimensional diagram. Now, this is 90 degrees right here. You see this? That's 90 degrees right there, between west and south. The angle of depression is going down to the fire, and this line right here is in the same plane as this is. So we have a triangle here. Okay, so this as well, there, and there. So 90 degrees here, 90 degrees there. So from this diagram here now, it says how far apart are the fires to the nearest foot? How far apart are the fires? So, similar to the question I started off with, but this is now a little bit more complicated because we're dealing in a three-dimensional sort of diagram here. So we're looking for this distance right here. Let's call it D, distance. Okay? So D is unknown. This is where you start looking at the diagram. You've got all the information on the diagram, and you start labeling the diagram as best you can with whatever information you feel that you can get. We need to know this right here. This is 90 degrees as well, right? So we have a right triangle here, a right triangle here, and a right triangle down here. These are all right triangles. They're drawn a little funny, I know. But I have an angle of 5 degrees up here, and an angle of 2 degrees up here. So what else can I draw on this diagram? Okay, so this is 90 feet high here, but what about this? Can I draw this? Can I fill this in? And this one right here? Yeah. So what's this degree right here? Yes, it is 85, because 85 and 5 have to add up to 90 degrees, right? So this one is going to be 80 what? 88. Okay? Okay, so we're good with that. And again, the height here is 90. So, if you look at this, you might be able to start to see, and I'm going to try and highlight this, the one triangle here, okay? So, this triangle here, this 90-degree triangle, has an angle of 85, and it has an adjacent side here of 90. So guess what? We could find the opposite side, which is a piece to this triangle at the bottom. So that's what you do first. And so what trig function are we going to use? Well, what are they again? I wonder. So, TOA. So which one involves opposite and adjacent? Yep. So you guys should be ahead of me even here. Tan 85 equals, so let's say this is opposite here, equals opposite over 90, which is the adjacent. So on the calculator here, if you figure that out, it's 1028.7047. Keep as many decimal places as you can, and certainly keep all of the decimal places that show up on your calculator screen for, in case you can use that later. So that's the first one here. So we've got 1028.7047, and now we move to the now we move to the other one here. Here's another opposite side, right? 88. So go ahead and figure out this side right here. Do that on your own. Take a couple minutes here and just finish the question, solving for D. You've got all the pieces that you need here after you solve for this, and you can solve for D. See if you can figure it out. Okay, so let's pick it up from where we left off. All right. At this point, you should have been able to finish that question without a problem, because I left you off at this point, right, where you were to find this value. This value right here is the distance between this point and this fire. This is a right triangle. You don't have any angles here, but you do have two sides of a right triangle, and so Pythagoras' theorem would kick in right down here. So you would use those two values right here and find the value of the hypotenuse there, right? Because D is the hypotenuse opposite of the right triangle, or the right angle. And so the distance is 2,775 feet. Okay? I'm going to give you a similar question to do, and I'm going to get you to do this on your own, and we'll double check your work with mine to see if you know kind of what you're doing here now. Okay? So, let me set this up for you. Alright, so in this example, what I'm setting up for you, this is a flagpole. This is flagpole 1. This is flagpole 2. Little flag at the top there. Okay? A person is standing. Okay, so let's say a person can view this from the ground. Okay, they're laying on the ground. Their head's right here, right in between the two trees. The two trees are, let's say they are 90 meters apart in total. And this person is exactly at the halfway point. Okay, so those two sides are equal. Remember, if there's a little kind of a slash there, and you see one slash on two different line segments, that means they're equal, right? And the angle of elevation of the tops of the flagpoles are this. We've got 20 degrees here, and we've got 25 degrees here. So the question is, from this diagram, given this situation, what are the heights of the flagpoles? Okay, what are the heights of the flagpoles? This is not as complicated a question as you might get, but I want to start you off with this. Make sure you can do this one correct. Okay, so you have about 3 minutes to do this question. Shouldn't take quite that long, but go ahead and do it, and just you can check my answer in a minute. Okay, so this one, not very complicated. It's just two separate problems, really. And so you have one 90-degree triangle over here and one 90-degree triangle over here. You're basically solving two separate questions just right here using tan. Okay, so that's what you should have gotten for that example. Let's set up another example. In this example, we have a house, and there's a person that's looking out the window of the upper floor of the house. They're looking at a tree, and they noticed that from the horizontal, they look up to the top of the tree at an angle of 20 degrees. So it's an angle of elevation of 20 degrees. They have also noticed that the angle of depression, looking down at the base of the tree, is 37. They know that they're 16 feet above the ground, and they're wondering how high the tree is. We did a question very similar to this. I want you now to complete this question. Alright, so if we work through this problem, it's very similar to one of the first ones we did. The first thing you want to find here is this length between the house and the tree here, this adjacent side. Did you get 21.23 feet? Yes? Okay. So now we use that length here in this triangle, which represents the triangle that's on top here. And we find out what? We're going to find out x, 7.72 feet. Now it's tempting to add these two up, but that's not what you do, is it? You have to take this 16 feet and add it to this 7.72. So what is that? 23.72. Okay, so I think I saw some of you added these two together maybe? Not sure. Anyways, yeah, should be 23.72. If it's asking you to the nearest foot, then you put 24 feet and so on. Okay, does that, are you guys agreed with that? Alright, very good.